Okay, chapter 12 over here, we've got vectors. You met vectors last year, but this year we're going to look at vectors in 3 dimensions. So the first thing to get used to is to how to draw the axes in 3 dimensions. So the book asks you to imagine that the x and y axes are on a flat plane like this, and then z axis is sticking out. I personally prefer to start off by drawing x and y axes like this, like we're used to, and imagine the z plane sticking out of the plane this way. So it's really personal choice. So the 3D coordinates, something you met before in a GCSE. So you've got x, y, z. It describes the position of a point with reference to one point, which is called the origin, which would be a point 0, 0, 0. The first thing we can look at is the length of a vector O to P. So vector OP is very often would be called the little p vector. This is a position vector of the point P, which has coordinates A, B, and C. You need to work out be able to work out the length of the vector OP. So this is like finding the length of the diagonal of that cuboid, which has the x coordinate, so it takes you from O to the from the origin to the point P. So that cuboid would have the one side of length A, which is the x coordinate of that point, then the height B, because that's the y coordinate, so that is B, and the depth C, because that would be the z coordinate, so C would be over here. So if you imagine the length of that longest diagonal can be calculated by finding using the length of this right angled triangle. So if you take it out, that right angled triangle, there you go. So this is O to P. This is, as we said, the height, that's B, that's the same as that one. And this is the diagonal of the base rectangle, which is A by C. And this diagonal is A squared plus C squared square rooted. So this one here is that diagonal, A squared plus C squared square rooted. So that takes you to OP, which is the length of the vector OP, as being B squared, so this side squared, then this side squared, and all square rooted. So if you tidy this part up, you've got the square root and then square it, so these are inverses of each other. So you're actually going to get extended Pythagoras theorem to 3 dimensions. So it's the longest diagonal, and it's the length of any vector is simply this vector, the directions, so A, B, C, all squared added together, square rooted. So if you have a point with the coordinates 4 minus 7 minus 1, and you are asked to find the length of the vector OP, so position vector of that point, you simply need to square each side. You can ignore that it's minus 7 because you only take the length of each side, and square rooted. So it's going to be 16 add 49 add 1, so it's going to be square root of 66. So that is the length of the vector OP. Let's have a look at example 2. How would you find the length of the vector that takes you from the point A to B? Well, let's find vector AB first of all. So it's end minus beginning, so it's vector OB minus vector OA. So it's 8, 6 minus 5, take away 1, 3, 4. So it's 8 take away 1, which is 7, 6 take away 3, which is 3, and minus 5 take away 4, so it's minus 9. So we're going to now find the length of this vector by using Pythagoras in 3 dimensions. So ignoring that it's minus 9, you can't put minus 9 squared, but you could potentially make a silly mistake doing it on the calculator. So it's 7 squared add 3 squared add 9 squared. So it's square root of 139. There you go. Which is, if you ask to do it to a number of decimal places, let me just check, 3 significant figures, it's 11.8. There you go. So just to make sure we understand this is to find the length of any vector. Let's find this vector and apply the Pythagoras in 3 dimensions. I've written this vector in the column fashion. Another way of writing it will be in I, J, and K notation, which we'll visit soon in the next section. In more general form, you simply are going to find the distance between 2 points by taking the difference between their coordinates and squaring these results, adding them together and square rooting them. There you go. So that's what you need to do. Okay, so let's have a look at the next example, which is example 3. In this example, we've got 2 points given, A and B. Now there is a B, the third coordinate is missing. However, we do know that the length AB is equal to 3. So what are we going to do? We are going to actually find vector AB. So from last year, remember, it's vector B, OB, position vector of point B, minus position vector of point A. You can actually draw, I like to draw them out, so you could write them as a column vector 5, 0, 3, and then B is 4, 2, K, and then the vector AB is that, take away that, or you need to think, what do I do to this value to get to that? So it's going to be take away 1. Okay, but let's just write it down. So it's end minus beginning. Okay, so you're going to get 4 take away 5, which is minus 1, 2 take away 0, which is 2. So over here, to get from 0 to 2, we need to add 2. That's why it's 2. And how do I get from 3 to K? Well, I need to do K take away 3. There you go. Now, what is the length of this vector, which is AB? Is simply extended Pythagoras. So it's 1 squared add 2 squared add K minus 3 all squared, square rooted. Now we are told that this length is equal to 3. So we just need to take those two pieces of information, make them equal to each other. So let's square the both sides. So you get 1 squared plus 4, 2 squared, which is 4, so it's 5, plus K minus 3 squared is going to be equal to 9. So K minus 3 squared is equal to 9, take away 5, which is 4. So that gives me K minus 3 can be equal to minus 2, or K minus 3 is equal to 2. This takes us to K is equal to minus 2, add 3, which is 1, or K is equal to 2, add 3, which is 5. So these are the possible values of K. Okay, so that takes us to exercise 12a. Make sure you complete it fully. Practice using the formula for the distance between 2 points.